So I'm just gonna get started. And we're gonna do 2 examples of possible steroids, and then we're gonna do 2 terpenes, like breaking them up and numbering them. So just to start, I drew the basic outline, and I apologize for the last weekend's SI session where I drew the wrong structure. I was looking off of somebody else's notes, and that was my mistake. So, but this is the correct structure. Again, you have the 2 methyls here. This is carbon 3, 17, I believe 11. And so if we look here, right here we have a carbonyl group. Here we have a chain. And here we have an alcohol. So if we're looking at these in order, right, we know that the chain is gonna go on number 17. So how did I draw this? I'm just gonna draw it like this. That's what it looks like. There's a carbon here and a carbon here, just to kind of break that down. Remember, any chain will go on that one. Now, when you're looking at what'll go on number 3, you want something that is polar. And she explained that when you're looking at number 3 and you have the option between an alcohol and a carbonyl, the carbonyl is gonna win on what's placed on 3. So that's placed on 3. And then we have an alcohol here, and so that will be placed on the last carbon, which is carbon 11. And then there's stuff that could be filled in later that she'll probably fill in for you. I don't get the point of her going back in and filling in the structures. I feel like that just eats up more of her time, but this is how you would answer this problem. Next up, we have 2 OHs, and then a long chain here. So chain, we have alcohol, and we have an alcohol. So since we have 2 alcohols, we know one of them is gonna go on 3. We have a chain, so remember that's gonna go on 17. So 1, 2, 3, 4, and one going up there. And then there's a carboxylic acid on the end. This is what it would look like if I were to draw it out completely. Carboxylic acid on the end. And then there's another alcohol that we have to place somewhere, and that is gonna go on 11. Do you guys have any questions about drawing these steroids and where to put things? Just remember, 3 is polar, 17 is chain, and then 11 is anything extra. So I'll leave this kind of key up. You guys can write that down. But that's the good rule of thumb. You're gonna get it right if you follow these steps. And remember, the carbonyl wins over the alcohol. That makes sense? Any questions about these? You're not gonna be given something that's like a trick. She's like, oh, there's a double bond somewhere. That's not gonna happen. She's just gonna give you what's gonna be on carbons 3, 11, and 17 and expect you to draw the backbone correctly. The methyl here, and the methyl here. All right, so next we're gonna move to terpenes. And remember, these are basically in sets of 5. They could be unsaturated or saturated, meaning there could be double bonds or there may not be any double bonds. And I think these both have 10 carbons. So you may get a bigger one where you get the 3 isoprene units, but just a reminder of isoprene. Let me quickly look up isoprene. Yep. Just a reminder, she asked you to draw an isoprene unit, which is possible. Double bonds are here and here. So that's isoprene. So she may ask this on the quiz as like a 1-point question, just to see if you know it. So when we're breaking down terpenes, again, you want to count in sets of 5. And again, all of these will be divisible, like they will have sets of 5, there won't be extra carbons because then it wouldn't be a terpene. So for this one, you can literally number these however you'd like. I'm just gonna start here. So 1, 2, 3, 4, 5, right? And there's a split down the middle here. And 1, 2, 3, 4, 5. That's how I would number mine. I recommend drawing this line to show the split, just to make it clear that there are 2 different units. And again, numbering does not matter for these. Does that make sense? Okay. So then for this one, I'm just gonna start numbering at the top. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, and there's a break there. And if you look, this specific unit is actually an isoprene unit. It's identical to this. So sometimes it works out that way. Just a reminder, you do not need to have double bonds in your unit. Like this one doesn't have any double bonds. And it doesn't need to look exactly like this. This one has a bunch of carbons going different ways. Does that make sense? Any questions about terpenes or steroids? They should be easy questions. They're pretty repetitive. And the pattern to solve them applies to all of them. So it shouldn't be too difficult. Am I good to erase? Next, we're gonna work on reactions, because those are gonna be what's a little more challenging. So we've been working with amines, which are fun to name. It's a different type of naming, unlike anything we've done before. So let's just see. So if we're looking at this amine here, it is a tertiary amine because it is bonded to 3 different carbons. There are no hydrogens on the amine. Now, if we were to name this, see there's an ethyl here, a methyl here, and then a 1, 2, 3, 4, 5, 6. There's a hexane chain right here. So how I would name this is N-ethyl, N-methyl, and isn't it just, yep, hexanamine. And the amine is on 2, so that would actually be 2-hexanamine. Again, when you have different substituents, like instead of it being like N-dimethyl, you do it, again, with the N is where the number would be, and then do it alphabetically, like normal. Everybody got this one? We're gonna do a fun molecule now. PR stands for propyl. This is our molecule that we're going to name next. So if we're looking here, 1, 2, 3, 4, 5, 6, 7. If I were to number it this way, I'm just calculating how to name it correctly. There's a substituent on 2, a substituent on 4, a substituent on 5, well, 2 on 5. So that would give me 16. If I were to number it this way, 2, 3, 4, 5, 6, 7, we'd get 2, 3, 4, 6, which would be 15. You guys understand what I did there to determine which way is? Again, we just number it both ways, and then whatever number the substituent's on, I added it here to see which one has the lowest numbering possible. So lowest numbering. So since starting on this side results in the lowest number possible for naming, I'm gonna number it that way. So I'm just gonna erase, there's 4, 5, 6, 7. So this is how I'm naming it. Right here, we have our amine, and it's a secondary amine because it's bonded to 2 carbons. All right. I'm looking super quick. So from how I've seen things named, they put whatever is N first, and then whatever has numbers after. And so that's how I'm gonna name it. We're gonna do N-propyl, and then we're gonna start numbering our substituents here. So we have a 3-chloro, that's a 4, remember, hydroxy. And this has 7 carbons, so that's gonna be a heptene. So what I'm gonna do is I'm gonna do 2 heptene 6 amine. When you have a double bond and you need to number it differently, remember the numbering of the double bond will come before that amine, because you can put the number for the amine right in front of it. Does everybody get that? So remember, the N in this case is going to be before any of the other substituents because what's on the amine is most important. Right. Any questions in regards to naming? I can do another example. Would that be beneficial? Yeah, okay. I'm going to erase this one. And again, I'm just coming up with these molecules on the spot. And so if you would like to make them up on your own, you can also do that. So, I'm trying to think. Oh, and then the last one I forgot, cis and trans. So we're gonna implement that in this one since I already erased it. So, let me count 1, 2, 3, 4, 5, 6, 7, 8. This one has 8 carbons. And when there's 2 double bonds, you can't write if it's cis or trans. So, I actually lied. We're gonna do a diene instead. So looking at this molecule, we know it's a diene. We know it's a diol because there's 2 oxygen groups, or dihydroxy. And then again, we have another, oh, this is actually, we're gonna use the ammonium ion. So we know there's an ammonium ion here. And so this would be, again, a tertiary amine because it's bonded to 3 carbons, but it's also an ammonium ion. So, let's see. Right, so I'm gonna start naming this again, is looking at what's attached to the amine. So it's gonna be N,N-dipropyl. There are 2 hydroxy groups on, I think I got a number again. So 2, 3, 4, 5, 6, 7, 8. So there's 2 hydroxy groups on 6 and 7, so dihydroxy. Then we have 2 double bonds on 2 and 4. So we're gonna go 2, 4, octadiene. And then the amine, or the ammonium ion, is on 1. Diene ammonium. Does that make sense why the diene is here? Again, those. And again, since it's not an amine, it's an ammonium ion, you end it with that ammonium suffix instead of amine. Everybody good with this? All right. So now we're gonna do reactions, and we'll get more practice naming with those because we'll name every molecule that we add to it. Alrighty. So the first one, I believe, is just a pretty simple acid-base reaction. And so when we add water to an amine, let me scratch that. When you add H2O, you're gonna end up with that ammonium ion. Again, this is a weak acid and base reaction. This would be the conjugate acid. This would be the base. This would be the acid. Water is a relatively weak acid, so we could write weak acid there. So we have our conjugate acid here, and we're gonna name it. So there's 1, 2, 3, 4, 5. So that's pentan 2 ammonium. There's a methyl on that, so we're gonna do N-methyl. And then 1, 2, 3, 4. So that would be 4-methyl. You guys good? Yep. Again, all I did was just add another hydrogen onto it. This one, since it's not that strong acid like HCl, you're not really gonna have any other product. This is what she's gonna be expecting from you. This one right here, the ammonium ion. And then this one, would we like to name this one just for extra practice? Yep, okay. So we can, I'm gonna number it the same way. 3, 4, 5. And we're gonna do, again, N-methyl, 4-methyl, and since there's no double bond there, I can put the 2. 2-pentanamine. So it goes from an amine to having that ammonium ion. And so if you were to look at the different forces, the intermolecular forces between these two. Let's just do that really quick. So we have ion-ion, H bond, dipole-dipole, and dispersion, right? This amine right here, there's no charges there. Even though there is a lone pair of electrons, that is not considered a charged molecule. So there's no ion-ion forces there. Hydrogen bonding, this is gonna be, we're gonna do in respect to a molecule of itself. So this is boiling point. Is there hydrogen bonding? Yes, because there's a nitrogen and a hydrogen bonded together. So yes. Dipole-dipole, the polarity of the bonds is gonna go towards that nitrogen, towards those lone pairs. So the overall molecular polarity would be like that, if she was to ask you to draw that. So yes, there's dipole-dipole, and then every molecule has dispersion forces. When we look at this one, there are ion-ion forces when it's interacting with itself because there's a charged molecule. So ion-ion forces here, yes, there actually is. This is probably one of the first molecules in this entire class where we're gonna say yes to ion-ion. Hydrogen bonding, now that nitrogen has two hydrogens bonded to it, and so that's gonna be even more hydrogen bonding than before. So I'm gonna put another exclamation point because that's even more hydrogen bonding going on. Dipole-dipole, again, the polarity, I didn't draw this molecule completely out, but it'd be similar to this. All of the, like the carbon-nitrogen bond is gonna be pointing towards the nitrogen, the methyl pointing towards the nitrogen, so yes. And the polarity would go through the molecule like that. And then, dispersion forces, yes. And so, just for theoreticals, let's just say the boiling point of this one is 34 degrees Celsius. This one would probably something more around like 70 degrees Celsius or higher. So when it has those ion-ion forces, those keep a molecule together very, very, very well. So this is just, again, a boiling point that I made up, but just for reference, this one would have a significantly higher boiling point than the other one. That makes sense? So I'm going to erase this. And we're gonna do an example with the HCl. So I'm gonna bring out benzene ring. Let me change that to an F. Right? So when we have a very strong acid, we're going to end up getting, again, that ammonium ion. And you're going to get that Cl that is attracted to it. So this chlorine, again, in solution, we could usually just write it like this, but knowing how these molecules interact, these are gonna be very close together. Like the cocaine example that she gave in class. I felt that was very appropriate for the weekend. Pretty funny. But again, these are interacting in a way that makes it a solid. So if we were to name these, let's start with this one because this is a little bit easier. This is an aniline. That is something that you should know. It's another form of benzene. It's gonna be like toluene or phenol. You're naming the benzene ring based on what's attached to it. So this is an aniline. There's an ethyl on that, so N-ethyl. You can just name number this way, 4, 5, 6, 3, 5, dimethyl. And then we could just write aniline. You don't need to write that it's an amine or anything because the specific name for the benzene ring, and this is aniline, right? You're adding the HCl, and then you end up getting you basically get the same thing. So we get N-ethyl 3, 5 dimethyl. And this one is kind of iffy, so you could do like aniline ammonium to show that it's now an ammonium ion. Just recognize again that this is still an aniline, but now it's an ammonium ion. And then, like she said in class, we could do chloride because this chlorine is going to be interacting pretty tightly with this right here. You could also do the dot and HCl if you don't want to write chloride. Either is correct, but I would just stick with the chloride because that makes it look a little nicer, sound a little nicer, but this is also correct. So if we're going to look at, again, intermolecular forces, because she may have you compare different amines and anilines on the quiz. I'm sorry I mixed up the order of these, but just a reminder, this one does not have ion-ion. The dipole, all of it's going towards the nitrogen's lone pairs. So the overall molecular polarity is going out and away. So yes, it does have H bonding. Yes. And dispersion forces. Yes. This one is, again, super strong. This one probably exists as a liquid right here. And this one is going to be a solid. And so the ion-ion forces, again, make it into a crystalline structure like a powder. And so yes, there's ion-ion forces and they are strong. In comparison to the last one, where you added just water, the ion-ion forces would not be as strong in that one compared to this one. This one has really high ion-ion forces. Dipole, yes, kind of do that over there. Hydrogen bonding, yes, again, it has more hydrogen bonding than before. And dispersion forces, yes. Just another example, again, I'm gonna do, let's do, this one may actually be like 70 degrees Celsius, and this would be something closer to like 200 degrees Celsius, because it's a powder and it's super strong. Again, these are just relative. I don't actually know the boiling points, but just to show that difference between them, the formation of that ammonium ion with the extra hydrogen bonding, and then the ion-ion forces. Does that make sense? All right. As she mentioned, in order to revert back, I'm going to move over here, and able to revert this back into its original aniline structure, methyls, you're going to be adding that NaOH. If you remember, we added that for the soap. That's what you guys added and made soap out of. By the way, those of you not in my lab, how did soap go? Did you make soap?
We made soap.
You made soap?
Yeah.
Nice. Because that was a fun lab, because you actually, I feel like everybody got results.
Yeah.
Depending on how much, but so I know sometimes people struggle with results, so. But yeah. In order to revert back to what she called a free base. That's a good term to know. You add that NaOH. And again, the name of this would be the exact same as the one over there because now nothing has changed about it. Dimethyl. And this would convert it back from a solid into that previously, most likely liquid state. You guys have any questions about this? What's up?
Just the free base part, is that only after it's converted back, or is it originally?
Yeah, this is after it's converted back because it's being freed from this solid form.
Okay.
So the free base is after it's been converted from the ammonium back to the amine. So this right here is not a free base because it probably just exists on its own. All right. Everybody good with these reactions? Now we're gonna move on to amides, which are basically carbonyls with amines attached to them. Alrighty, so the basic structure for an amide, which may not ask you too many questions about this yet because we haven't learned about them that much, is gonna be this. Remember, these H's can be replaced with a carbon. So just this basic structure, you can tell it's primary because this nitrogen right here is only bonded to one carbon. And I know it was a question in class, do you need to draw in the lone pairs? No. If it helps you kind of visualize the way the molecule is like drawn, so like this is how it would be drawn, then you can add them in, but you do not have to. I add them in subconsciously most of the time just because I like the way it looks. So, again, the difference between the amides and the amines is that carbonyl group right here. Remember, the carbonyl again is just that double bonded O to a carbon. So, again, just to review the reactions from last week, when you have this, and you add, let's just do a random alcohol, you are able to get that ester from it. So 1, 2, 3, 4. This is now an ester. It went from a carboxylic acid and an alcohol to an ester in the presence of acid. She may throw another one of those on the quiz because she said that it needed worked on the last quiz. So she may add another one just to see if you guys like studied it and learned it. The final reaction, or the final few reactions we're gonna do are back to more these amines and amides. So everybody good with this one? This is just a review one. So I'm gonna do amine there. Yep. So when we have an amine, and again, this one is a primary amine. This is still a carboxylic acid. When you add heat to it, this is again the signal or a symbol for heat. This is what you're gonna get. When you add heat, you're gonna be dropping one of the hydrogens on here, and so it can then bond to the carbonyl and form that amide. And this amide is now secondary because it's bonded to one carbon here and one carbon here. So it went from a primary amine to a secondary amide in the presence of heat. Would you guys like me to do another one of those? Okay. I will do another one. And we're just gonna, again, we're gonna start with the carboxylic acid each time. So that's just gonna be the one, this is a generic carboxylic acid. And you guys did not learn how to name amides yet, right? You didn't name them? Okay.
No, we just did a reaction on
Okay, sounds good.
them. Just that there might be an extra credit reaction on how to make things.
Oh, yeah. Let me see. Acid and salt reactant base. I'm pretty sure, was this the extra credit reaction? The amide?
Think so?
Yeah. So, I was gonna say, I'm pretty sure this is the extra credit one, but we're gonna do a we're gonna do this one. Similar number of carbons, just different placement of the amine. This one is a secondary amine. And again, when you add heat, I'm gonna put the N here, and then the chain with the methyl down here. So remember, when you add heat, whatever hydrogen is there drops, so it can bond to this carbonyl. And so we just took a secondary amine, there's a carbon here, to a tertiary amide. So again, these are just like the ester ones, except in the ester ones you add acid, and this one you add heat. But it's very similar, the process of dropping that H and allowing it to bond to the carbonyl group. Everybody good with that? Good, good, okay. Now we're gonna backtrack a little bit, and we're gonna look at the reaction that creates a free base. So I'm going to erase this. And we're gonna have this is our acid of the reaction. And this is a pretty strong acid because it has that positive charge. And then we're gonna add the NaOH solution. And this is a base. This is a pretty strong base. Let me try and get another marker. And so, when you add these together, that's even worse. When you add these together, this negatively charged OH right here is gonna pluck one of those hydrogens, right? Restoring, this is now a free base. And it forms H2O and the sodium, oh, sorry. Just to add to this one, when we make one of the ammoniums, right, you're usually gonna have a chloride ion if you added HCl to get there. And so when you have the Cl here and the NaCl, it's gonna form this spectator product. Spectator product of this. So these are the two main products. This is the spectator product. And so an example question, we can just do this whole process one more time, just to show what an example question may look like on the quiz. Can I erase this? We're gonna do the full process again of making it into an ammonium ion and then making it a free base. We're gonna do this. You're not gonna be expected to name this. I'm just drawing something fun, just to show it can react with anything. Remember when we add HCl This hydrogen is gonna end up going with the amine, and right now this is a primary amine. So, I'm gonna end up getting NH3 plus with the Cl right next to it. Again, this is gonna be more of a liquid, and this is gonna be a solid. Then when you add the NaOH, this NaOH is gonna get one of the hydrogens, and it's gonna convert it back into a free base with the formation of water, because remember it's grabbing one of the hydrogens, so it's gonna form H2O, and then the spectators down here are that NaCl from this and this binding together. This is something I would expect on the quiz, so she could incorporate kind of two different reactions into it. The making of the ammonium ion, and then restoring the free base. Any questions about this? Vocabulary or anything? Okay. Looks like that is everything that I have. Again, it's not nearly as much as last week. That was a lot to remember. Do you guys have any individual questions? Any problem you'd like me to do another example of? Okay. That sounds good. I don't think you guys have lab anymore. I think that was the last one. So good for y'all. I haven't heard anything about a lab exam. So I know she usually has, yeah. She usually has one for organic, but since you guys don't have a lab notebook, you shouldn't have a lab exam. But just a reminder, your next exam is in lab after Easter break. So it's coming up. And I don't think, I won't be here Sunday, like next Sunday, obviously, because of Easter, but I may hold one maybe Monday night because we have off school. So I will probably do that, so that's easier. Any questions, guys? Are you guys good? Yep. All right. Thank you, guys. Have a good night.